Hello and welcome to another tutorial. In the previous lecture, we looked at the while and do while statements, and we said that these are common constructs for doing repetitions, right? Loops means there's something that you can do repeatedly, and then obviously you want to have an exit condition when the loop terminates. Sometimes actually you want to never terminate the loop in its normal way using the condition. So you set this to true, say while true, and then you use break statements. And then we saw that in the bytecode of the while, what happens here is that once we put a condition and then we have a body, we saw that the first thing that happens in the bytecode is that we have a goto instruction. At the very first thing is a goto that jumps to the bytecode instructions that evaluate the condition. And we saw that we jump to goto, and this goto goes to iload 0. So basically it loads the x value and then uses loads a constant 10 and then it checks the condition. If the condition holds, then we jump to the actual body of the loop, right? So let me bring up the bytecode again. Let's see. So this is test 2 here. All right, let's zoom in a little bit. All right, so basically what happens here is that these two lines for setting the integer to 0, and then we have a goto to line 30, and then at line 30 we start doing, so these three lines 30, 31 and 33, I load 0 and then load 10 and then compare the x with the value of 10. This is the condition. So this whole thing is the while loop, the condition and the body of the while loop, right? So we start by jumping to the instructions that evaluate the condition. If it's true, if integer compare less than, right, that's the condition. And then we jump to line 5, which basically executes the body of the while loop, right? So we get the out field of the system.out, load a constant, a string x equals %d, and then I const 1, and then a new array. So you might wonder what's going on with this, right? What is this icons? After we load this string, what happens with basically all this stuff, right? Icons 1, a new array, Java lang object. Why are we creating an object array? Why do we push it and duplicate it on dup? Dup means duplicate the last element on the stack, which is an array object. Icons 1, I load 0, so we load x. We know that loading. So basically after we get a hold of this out, before basically doing a print line, we have to evaluate this expression, which is the argument of the print line. And all these lines that I highlighted, 10, 11, 14, 15, 16, 17 and 20, all these things before we get to the formatted, basically they all trying to actually also formatted is part of it, right? From loading the string x equals %d all the way to when we call the print line. All these lines of bytecodes goes to evaluate this formatted function. And it's very interesting that in the bytecode, this formatted, we're using a method, Java lang string formatted, and which takes an object array. So basically, let's look at this formatted. So it takes an object array. It doesn't really specialize on integers, for example, because it doesn't know what you're trying to do, right? So you specify the formatting of integers, because we know that every object has a string representation. So you might use %s and pass an object. That's why formatted has only one basically version that takes an object array, and therefore that's why you see this basically I const 1 and a new array Java lang object. Basically what this does is says whenever you write something like a object array, let's say a object array or array equals new object array, right? New object with one element, right? So formatted, the argument is a vararg, which means vararg translates into an array, right? So when you pass x, the compiler realizes that you only have one element. So first it has to create this argument, which is an object array with one element. That's why we first the first thing is to execute this command. And then in order to do that, we have a literal, which is 1. That's why I const 1. We push it and then create our object array, a new array. A means reference or object type array, pointer type, new array. So we create an array of pointer types or reference types, which is of type object, Java lang object. But then we have to duplicate it on the stack. And the reason is that if you duplicate this, you just pop them up the stack when you go to execute the new one, right? So you duplicate it. Dup means just duplicate it, and after that we have icons 0, and so basically what happens here is that after we create this, remember we're still trying to build the argument of this formatted, which is an object array. So you create an empty array, right? The first thing is to create an array with one element. You just create it, but it's still empty, right? It's still empty. Now if you recall from our discussions on the objects, we said that when you create a new array, the elements are uninitialized. Now you have to initialize it. You have to say this object array at index 0, remember the array index starts from 0, is equal to x, right? But x is an integer, array is object type. You have to convert it to object, right? So the way we do it is what this does, you have to convert it to an integer type. We know that any primitive type like int has a wrapper type, int x for example. Now we saw that the constructor for integer is going to be deprecated and probably removed, so we use the static factory method, value of x. Remember, polymorphism allows us to do this because integer is a subtype of object. So an array, a generic type array, an array of type object can hold any reference type, right? So behind the scenes, compiler does this. So all these two lines of code, so from iconst 1 to creating the array and then duplicating, and then remember when we write this line of code, we have an integer literal 0 here. That's why we have to first load it, iconst 0, and then I load x. We have to get the value of x and then call the static factory method of value of to convert x to an object type, which is an integer, and then a store. We're going to store it. Where do we store this integer? Store it in the last element on the stack. That's why we duplicated that, right? So, and the last element on the stack is this basically object array. All right, so and then finally we call this formatted method. So this seems very innocent, but the fact that the parameter to the formatted is an object array, it makes the basically the bytecode complicated. Now we've saw that in the previous examples that another way obviously is to use concatenation, and we saw that behind the scenes the compiler creates a string builder. So the question is which one is more efficient? Use the formatted. The downside of the formatted is that obviously you have to, behind the scenes, the compiler has to create this object array and initialize it, and then proceed with calling the formatted. With the concatenation, you just the compiler creates a string builder and then calls the append method. So in I guess for a simple case like this, both of these are basically more or less the same, have the same efficiency, but you have to evaluate your code, profile it to see eventually which way is the more efficient way, right? So this whole code from loading this string to evaluating, calling the formatted, getting this string with the formatted version of it, which this % is replaced with the correct value, and then we call the print line, and we saw that the plus x translates into I increment, right? And then I increment at index 0 on the stack. Remember that x is on the stack at index 0, so we just increment it by 1, right? And then the last three lines, I load the x 10 and then compare. These are the conditions. So the way that the bytecode works for the while loop is that we said that while we always check the condition first and then decide to whether execute the body of the while or not. And in the bytecode, what happens here is that we immediately have a go-to instruction, right? And go-to goes to the instructions that evaluate the condition. And if the condition is true, we jump again. So it's two indirections, and indirections are always bad. So it's always best to avoid indirections. Indirections means just jump instructions, because then you have to jump back and forth, and then that's usually inefficient, right? If you can write your code in a way that it has less indirections, then it's usually more efficient or faster to execute, right? All right, so now let's create a new method and look at the basically the do while. So public static void test4, and then I'm pretty much going to use the same code, int x equals 0. And then let's say do, we have the body, and then while x less than 10. Remember, we have to terminate this while with semicolon, otherwise the compiler would assume that this while is part of a separate while loop. So if I don't hit semicolon here, the compiler is going to give me a compilation error, and it tells me that you're forgetting a semicolon, right? So all right, and then we're going to do the same thing. We're going to do this formatting here, and then ++ x. All right, let's so as soon as I save this, Eclipse compiler compiles this. Let's search for test4, and let's see what happens here. All right, so icon 0, I store 0. So this is just initializing x, right? We have a literal 0. We have to load it and then push it into the x at the 0th index of the stack, or the first position, because this is a static method. And now let's see what happens here. What do we expect? We expect, obviously we don't expect that go-to, because remember, for the while we had this go-to because we have to check the condition first. So we have to jump to the instructions that evaluate the condition. But here we don't. We have to evaluate the body first. So as soon as we have x, we jump to the body, and the body is exactly the same, right? We get the static field out from system.out, and then load this constant, go create your object array, and then duplicate it, load x, initialize the array object array with this x value, and then call the formatted, and then yeah, object array formatted print line, and then I increment. And then after that, we automatically jump to the condition. I load 0, load x, push 10, and compare, and jump to 2. So you see, this only has one indirection. Now with the while, if we go back to the while, which was, I believe, in test 2, if you look at this, so with the while, this go-to happens only once, so it's not a continuous jump. So first you jump to the condition, check it if it succeeds, if the check is true, and then you don't jump to the go-to, obviously you jump to the body. So the only difference, you see, all the lines between the while and do while is exactly the same. The only difference in the bytecode is that with the do while, we don't have this go-to instruction, because that instructions just tells to jump to the condition and evaluate it first. Here we just continue with the body, because do while says that go and evaluate the body first, and then jump to and then the condition evaluation automatically or naturally comes after that, right? So the only difference is that no go to instruction, right, in the bytecode. So only one line of bytecode, the difference is only one bytecode. So right, so in terms of efficiency, they're exactly the same. So there is no speed difference. You don't need to worry about whether to use while or do while. I mentioned in the previous lecture that you can actually we don't really need a do while like as a separate construct, because using the while and break or continue, you can simulate something very similar to do while. but the fact that we have a separate construct means you can have better optimization in the bytecode, right? As you can see. All right, so let's jump to the next loop, which is important and widely used. This is the for loop. So for usually is used when you know how many times you want to iterate through the loop, right? So usually you have some sort of counter. With the while, you kind of the idea is that you only have a condition. Obviously this condition may have a counter in it, right? That's why we have here, but you have to explicitly define the counter outside the while. So you cannot say int x and then x less than 10, right? You cannot confine the counter of your loop as a local variable. You cannot confine it to the scope of your body, and most of the time that's what we want, because I want to have a counter like x or I, but I want it to be really confined to the scope of my loop, and outside of that I might want to define another loop. And usually the convention is that to always the same name for your loop variables, like I, j, or count or something. So the fact that the counter is confined to the scope of the loop for the for loop construct, it's beneficial, it's more handy, right? Think about it like that. So the for statement provides a compact way to iterate over a range of values. If you're familiar with C++, you know that for loops in C++, when you're, for example, looping over an array, or even in Java when you use the enhanced for loop, which we will look at it later, it translates into iterators, right? So if you're not familiar with iterators, that's fine. We will look at them in a more advanced lectures in the future. But for now, if you know how many times you want to iterate over something, or maybe how many times you want to execute some body of the code, right? Then you can use for loop. Programmers often refer to it as the for loop, because the way in which it repeatedly loops until a particular condition is satisfied. The general form of the for statement can be expressed as follows. You have the for, just like the while you have the argument inside around brackets, and just like the while loop, you can have one line of code without any scope defined. If you want to have multiple statements, right, multiple lines of code that define multiple statements, you have to define a body or a scope using a pair of curly brackets. Otherwise, only the next line after the for is considered part of the loop. Again, I repeat this over and over again, because sometimes this can cause some bugs that people have a hard time identifying what's going on, right? So the best practice, always use a pair of curly brackets. Always define a scope for your loops, for or while, doesn't matter, even if you have only one statement, right? And as I mentioned before, you can even configure your Eclipse IDE, the auto formatter, to when you do save, for example, your Java file, your source file automatically formats your code and make sure that everything, your for loops always have this pair of curly brackets, right? So what is the construct for the for loop? There are now this is one of the exceptions where the arguments actually have or accept more than one statement. We will see other constructs in Java that have the same behavior. One of them is try with resources. In the try with resources, the argument also accepts more than one parameter. But while loop, for example, the argument doesn't accept multiple statements. It only accepts one statement. And whenever you have one statement, you don't use a semicolon, right? You have one statement, and in the while loop, that statement has to translate to Boolean true or false. Now, what I mean by that is, let's say I define int I equals 0, and then say I less than 10. So this doesn't work, right? So this doesn't work because the while doesn't accept multiple expressions, right? It only accepts one expression or statement, and it has to evaluate to a Boolean. I cannot say, for example, x minus 10, because now if this was C++, this was actually valid, because in C++ bool is just 0 or non-zero. So there is no strict there is no strict rule in C++ whether an integer can be considered a bool or not. But in Java, they try to be very strict about this. So the condition or the expression in the argument of a while has to evaluate to a Boolean. All right. So you cannot say while x, for example, because x is an integer and Java doesn't allow implicit conversion from int to bool. Now if I say bool or boolean, cannot cast from int to bool, obviously this is not allowed, right? So let's say x less than 10. All right, so for accepts three statements. The reason I say a statement is because each one of these has to be terminated with a semicolon, and each statement can have multiple expressions, and we will see examples of that. That's why I say that these are statements, not expressions, because in general a statement can have more than one expression in it, right? And then we can do some initialization. So we have an initialization statement, which basically usually we use this to define the counter that or the index that we use for the loop. And then the termination condition. So initialization, the statement, if it's only one expression or more than one expression, it doesn't have to evaluate to Boolean. The termination statement, it has to be one expression, and that expression has to evaluate to a Boolean. And then the increment, and the increment, it's called increment here, but in general this is another this is the basically loop action, or what happens after we execute the body of the loop, right? So it's called increment here, but this can be any expression. Usually we use this to increment or decrement the counter of the loop, right? That's why it's called increment here, but general it's just another statement that you can put here. And again, I mentioned that this is one statement. It can have multiple expressions, I believe, and it doesn't have to evaluate to a Boolean or something, right? It's just expression, right? So initialization and increment here, they don't have to evaluate to any type. Termination has to be one expression that evaluates to Boolean, right? And the way this works is that when the compiler when the runtime JVM hits the for loop, the very first thing that it does, it runs this statement, right, before doing anything else. If you can define any variable here, let's say int I equals 0, you can do that, that's valid. And whatever variable that you define in the initialization, its scope is it's like a local variable for your for loop, right? Its scope is limited to the scope of the for loop, which is nice. So after the initialization is done, we run again the termination condition. So just like the while loop, before executing the body, we check the condition first. After the condition is checked, if it's true, we run the body, and after the body is done, we come back and then we execute the third expression here. So basically termination is something that is evaluated before executing the body of the for loop, and after executing we jump to this expression, the third one, we evaluate it, and after that we don't do initialization again. That's done. That's only one time. After executing this increment or the third expression, we jump back to the termination and re-evaluating, right? So after executing this third, we don't execute the body again. We first jump back to the termination, evaluate it. If it returns true, we run the body and then come back and execute the third expression, and then jump back to termination condition. And this goes on until either the termination becomes false and we jump out of the loop, or we might have some break statements or continuous statements in the loop. Again, for loops, just like while loops and do while, they also accept break statement or continuous statement. So this was the brief introduction to the for loop. In the next lecture, we will look into more details of the for loop and also what happens in the bytecode. Please stay tuned, and I'll see you in the next one.